incredibly honored, and what a venue. As I'm looking out the windows here, I just feel so honored to be part of this, and the energy is real in terms of the sense of collaborativeness. I thought for today, I might just share just kind of a practitioner's perspective on some, lessons learned, mistakes that we've made, things we've kind of little insights we've gleaned in terms of the past couple of years in kind of playing the role of a red team for different uses of machine learning in these kind of high stakes environments. And by kind of high stakes environments, I mean things like, think everything from a machine learning system to optimize, IRS taxes, and thinking about, how that might be gamed and attacked by people trying to evade kind of taxes. Things like, computer vision systems that are driving platforms in kind of national security contexts that might be, targeted by kind of nation state type actors, and even things like, can we kind of red team for privacy in applications having to do with like health. And I'll say it's been an incredibly humbling and exciting journey the past couple years. And it's been, sometimes I feel like I'm the Forrest Gump of like machine learning or computer vision. I found myself in all these crazy situations that I don't even deserve to be part of. And I'm like, wow, I can't believe I'm here. And in fact, as part of today, I'll tell you the story of how I found myself in the middle of the desert of Utah in Area 52, testing some machine learning system for security. So I was like, I cannot believe this is happening. So I'll get to that. But first, let me back up a minute and give you a little context in terms of kind of where we're coming from, and then I'll back into kind of latest events. Hiram, you were completely right in terms of kind of where I'm coming from. For most of my career, I was just trying to get stuff to work. I mean, as a computer vision person, you like picked exactly the right chapter in my life to start with. This was my life most of the time. A little Subaru Outback didn't last more than 30 seconds in the first grand challenge. I met today someone that I knew some of the people who were also failing. So we were in a club that didn't last more than a minute. So I was very just humbled. And for most of my life, this is what research felt like. I would be in a lab, we're putting things out there in the real world, and I just only to see them, basically fail miserably. So I'm telling you, this is really what my life felt like. And you know what? I was okay with that. I was totally okay with that, because you have to remember, we're living in a different time right now, and it feels like a certain kind of sense of optimism. But at the time, this was like over 10 years ago, we were all taught that, hey, you got to take a moment, like, let's remember where we're coming from. If you think about, that kind of go back to Dartmouth College and, summer of 1956 and thinking about, Professor McCartney putting together this, incredible kind of workshop that had probably energy of the one that we're feeling here, this kind of collaborativeness. And we were all taught that, there was early days, there was, very interesting kind of discussions with these group of people. They had different perspectives of what artificial intelligence could be, but they all kind of had this sense of optimism that maybe they could imbue computers with, these different areas of intelligence. So that's kind of, what we were taught, that there was this kind of early days, kind of spurred by kind of Cold War competition a little bit, funding from government research. There was this kind of sense of optimism in the air of like, hey, we can solve this thing called intelligence in maybe a generation. And in fact, the field that I ended up focusing on myself with computer vision was born during those early days. And, I was taught, that basically, what's crazy is that this whole area of computer vision, which, today is still not solved, was actually given to summer interns at MIT as a summer project. As is notorious, they were like, hey, maybe they'll solve this vision thing in summer, and then maybe by next summer we'll do some other stuff. So I say this because, we all knew that didn't come to fruition, right? Everyone learned, shoot, this is much harder than we ever imagined. So even people like, Minsky, who's on like, we're going to solve this thing in a generation. We all realized then, oh, shoot, this is much harder. And then we all know the story. There was all these different AI winters. And I say this because by the time I kind of came around, we had that kind of humility. And so I was perfectly content to chip away at the science and maybe make a contribution in MATLAB or two. And that's kind of the sense that was at the time, right? So I just want to remind us that, we're living in a different world right now. So in fact, and you guys, this story has been told a million times, right? There's a group of people back in the late 80s, early 90s during one of those kind of AI winters that were still plugging away at some of these neurally inspired approaches. If you ever talk to Jan LeCun, he'll never let you forget it. He reminds everyone at every conference he speaks, but he says, he was one of the few people, and you're seeing him here on the screen, as he was part of I think either Bell Labs, doing kind of these neurally inspired kind of neural network-based approaches to do handwriting recognition. So, their funding ran out. Some of them went over to Canada. Some folks went to France. Basically, no one was really caring or paying attention. We all know that that's been big change. And now that's widely recognized as being a huge kind of been a pivotal set of capabilities. But I want to remind you, too, a lot of us who were in the field did not see this coming. And it's just, I keep reminding myself, we have to have that sense of humility and keep open for surprise. Because I'll tell you, actually, before joining MITRE, where I'm at right now, Jan LeCun would come to brief us all the time. In fact, this is him here trying to convince everyone to do this deep learning stuff. And you'll see me all the way off to the right over here, completely ignoring him. And actually probably a little bit hungover with that port bottle of wine or something's going on. I don't know what happened there. But basically, I say this to say that, even those of us who were in the forefront in seeing this happen, kind of didn't see this surprise. And I kind of want to ask ourselves, what surprises are in the room right now? What things are we ignoring? What things are going to catch us by surprise? So always keep that sense of open-mindedness, open for surprise, humility. You never know. So at the time, I was all about these like topic models were the sexy thing. And I was like, neural networks, no way, that's so 80s. So you never know where the surprise is going to come. So we all know the story, what got us to today, right? We had this kind of inflection point, massive, labeled data sets, ImageNet, the compute, the story's been told before. And we had, I'm going to fast forward kind of to closer to today, we had, I guess around 2016, 17, really at that point, just this Cambrian explosion of, creativity in the commercial sector and academia. It was just like, wow, this is really happening, and incredibly exciting. So at that point, what I started pivoting towards was, hey, can we apply some of these techniques to problems in the public sector? That's the things that I've been really passionate about. So, everything from helping address climate change, looking at kind of better health outcomes for patients in various contexts. There's a lot of potential in areas having to do also with national security. So how can we support these different domains? So that's kind of naturally where I started gravitating towards and have spent a number of years working on. So it's kind of high stakes, consequential applications of machine learning was where I went. So that was around 2016 to 17, kind of the mindset that I was like, oh my gosh, there's this Cambrian explosion of techniques, and they're really starting to work, unlike my little robot fails. So, what are the areas that could benefit from this? So at that point, I remember being in my office, and I got a knock on the door, and there was this like super intense Marine colonel at the door. And it's like, oh my God, this guy is like, if you imagine like you're like your canonical super gung-ho maverick Marine colonel, it's this gentleman here. His name is Colonel Kukor. And he was like going around the town just thinking about, hey, I've heard that this computer vision stuff is good enough. And I want to start kind of a Pathfinder program to see if we can apply it in a kind of national security context. And he was a little skeptical. It's like, is this stuff actually work? And I told him, do you have a laptop? And he brings out his laptop, and I think a MacBook Pro that at the time they still had NVIDIA GPUs before they went and did their own thing. So it had enough juice that I knew, okay, maybe we could do something here. So at the time, I just told them, we'll download it. I don't know if you guys have ever used YOLO from the computer vision. So it's just like basically with one line, you're up and running. I mean, that's so we get this thing going, and it's running object detection live on his, and he's like, whoa, this actually really works. I mean, this is incredible. So already I thought it was kind of funny that we have a super intense Marine kernel. And I don't know if you guys have ever gone to the YOLO website, but it's a hoot. This is what it looks like. It's like ponies and everything. So I was like, what is going, this is a weird world. I suddenly got this guy in the uniform downloading this pony code. It was like already the beginning of something that I thought was just kind of a weird confluence of things. The beginning of getting some of these worlds to think about some of these high stakes applications started with this kind of silly demo. But then I remember the next day I told them, hey, do you want to come with me? I'm going to a conference. This is more than a demo. You could see like really cool stuff. I'm going to a conference in Hawaii tomorrow at CVPR. Do you want to join? And sure enough, got a ticket. And then suddenly I'm in between a Marine colonel and a 3-star general. I'm like squished in the middle of a 14-hour flight over to Hawaii. And that was the beginning of something that was really interesting. We're trying to get, researchers and, people that are working in these kind of high stakes environments to think about how thoughtfully and safely and securely they might develop machine learning, enabled solutions. So at that time, the DoD started a project called Maven that was mostly focused on computer vision, like trying to do, like process data that looks like this. It was really interesting. At one point, we had fantastic researchers, and I remember we were in the basement of the Pentagon, and it was like a room that looks like this. And on the left hand side, we had a bunch of guys and girls who were like wearing their hoodies, or just kind of your typical machine learner. And on the right hand side, we had a bunch of these like Marine colonel types, and it was just like, wow, this is a weird world. But there was a lot of collaboration in terms of how do we develop some of these solutions. So I felt like that was going to go in a good trajectory. But suddenly, maybe the role that we could play is really thinking about, hey, we're going to need to secure these systems, right? We're going to put them out there, and we're going to need to think about that. So I remember in this kind of meeting that when we had these guys, folks in hoodies, and then the Marine colonels on the right, I remember writing a little note and, saying, hey, do you think we should start like a red team to really think about some of these, anticipate some of these security vulnerabilities and mitigate them and make recommendations? So, this is one of those where it's like, be careful what we ask for, because then this is what took me to that crazy Area 52 and like in some crazy desert proving ground, because at that point I said, yeah, I think we should start a red team, and can you help us figure out what that should look like in kind of this new generation of machine learning systems? What are the attack surfaces? Can you actually demonstrate a methodology that's meaningful, and what would that look like? So what we did was and this is kind of a bit of an eye chart, but just to give you an idea of how we were thinking about it originally. So originally it was really about, you think about in the top, you have these high stakes applications of AI where there might be a feasible threat. And in the bottom, you have understanding of things that we're talking about here. Like, hey, there's these emerging attacks, there's these possible vulnerabilities. And the idea was to have a team that has like credible access models and kind of attack scenarios, and thinks kind of in an evidence-based manner. Should I be concerned or not? Is this an actual possibility? And anticipate some of these potential attacks to a kind of a machine learning system, and then thinks about how you then might do research to either mitigate these, or maybe you need to think about how you change the system overall. So that's kind of the spirit of this team, was to do that. And the idea was to bring people that were very creative, technically based, but also multidisciplinary, right? So just from different backgrounds. So kind of a day in the life of what we were doing at the time. And by the way, from my background, as you guys know, I'm a computer vision guy. So I'm sure there's people in the room here who's like, this is like standard. Maybe we rediscovered something that is like, I know that a lot of this is standard in some areas. So I definitely am excited to talk with some of you guys in terms of like best practices from the cybersecurity world. So this is very much like, I hope it's not a cringe. And I was like, yeah, this is what you do. But basically, the kind of our day in the life was, we would spend a lot of time, early days, we were kept separate from a lot of the, the companies that were developing some of these systems. And we would do a lot of kind of open source kind of recon, right? So what publications have they got? What are their patents? What are the, usually people don't reinvent their like favorite machine learning things. We all have our favorite things that we use, and we keep them around for a couple of years. So we would sign up for an API. If you're a company that sells free, you give me 1,000 free API pings of your service. Well, that's a lot of signal there in terms of being able to potentially approximate your model, because that's the second phase of the usually kind of a day in the life, is we would try to generate an in-house proxy of the target system. So basically try to have a mock-up in meaning like you have an approximation of the model, whether it's because you had significant access to the API and you're able to essentially approximate math and math function, or you basically have some open source intel that tells you, oh yeah, they're using YOLO in this case. Okay, so let's just bring in a white box version of that. And then the kind of third phase of the kind of day in the life was then developing kind of an attack plan. Like, what are we gonna, like, what is a potential thing that could actually have an impact on the system? And then it was like kind of go time, right? Then you actually then execute that, and then you assess in terms of what was the effectiveness of that, that actually have an effect on the real system, not on the proxy. So that kind of gives you an idea. And so that we had like a first set of events, and these were, a lot of these were computer vision systems that are like, taking measurements and input from the physical domain. So one of the early days, a lot of it focused on kind of physical domain potential attacks. And I'll just give you an example of what that one that I was talking about in Area 52 here. But it basically involved a whole bunch of these, physical domain adversarial examples that I'm sure you guys have heard about. And this is kind of what it looked like. So this was a ScanEagle full motion video platform. It's going out there recording stuff. And of course, you'll see in just a bit these little, weird adversarial patterns that were, we had to optimize for different times of day for atmospherics. And you'll see it were pretty effective in this case with, gray box-ish knowledge of a system. You're able to make it hallucinate all kinds of silly things. So that was the first kind of early days of some of this. And I'll say, I mean, for me, I was like, man, I can't believe that, you read this in the papers, making these things work in the real world, as you'll see, is a different story. And I'll get to that in just a bit. But, I was like, I was like proud. I was like, I can't believe this is really cool. Like, this is actually working. We won. The attackers were able to, that was my original feeling, is like, this worked, game over. I'm going to walk in there and these generals are going to be like, amazing. Yeah, so that's what I had in my head. We even had like really creative things. We had to work, like, I've never seen this, like basically infrared adversarial attacks. So we have a woman on the team who's like rare combination. Her name is Shiri. They could solder really well, but then also as a machine learning hacker. So she was generating these like thermal adversarial patterns. It was like really cool. So I was very proud of what we did during that first set of events. We even had hardware level kind of attacks that allowed us to do like side channel of like at inference time at the edge by just looking at essentially, emissions that are from the GPU itself. You can understand what, computations are happening. It's pretty impressive. You could do that to some extent from a distance. So we had built all these, we had these like physical domain. We go out there, we detailed analysis in terms of here's all the different success rate of all these different attacks. And this was the first kind of another humbling moment for me, because I went in there again expecting people to be like, this is really cool. Like, oh my God, I can't believe you pulled that off. But I remember really clearly like presenting all this, and like at the end of the day, they looked at us like, this is really cool gizmos you got there. I think they were calling them like AI lures or something like that. I was like, and they said, so bottom line, I remember this guy, his name is General Shanahan, he was like basically like bang the tables, like, Mikel, so do we deploy the system or not? Like, I like your little metrics and everything, but bottom line, is this something that I should like shelve the system and not deploy it? And I was like kind of taken aback, because I didn't have an answer. I didn't really know, yes, I have these metrics for you, but like, what does that mean from an operational perspective, from a business perspective? What is the actual meaning of that? So my first kind of key insight was that, and by the way, a lot of these ML algorithms are susceptible to this, not just yours, sir. I mean, so basically, my first kind of realization was that, I mean, almost like a really effective kind of red team is not just bringing in those cool gizmos and amazing technical team. I think I learned at that point, it was very important to hone our skills and being able to translate the kind of technical impact to mission and kind of business impact. That was kind of a key thing. How to add context to the findings and be kind of measured about what we're learning in the context of kind of mission and business impact is kind of a skill that at least I had to hone. Basically, coming in there with these academic metrics just was not going to cut it. So being able to ground the analysis, translate that to decision makers to then, overall increase the security posture of a system was something I had to learn. I didn't have that. And I guess my first bit is do not go in there with like attack success rate and all these cool things and expect to like get the slow clap. It's like, this is amazing. So I was humbled by that, and I'm still learning how to hone that, but that's something that I realized you can't discard. The other thing that I really quickly learned, and we were really lucky during these first years, because we were working straight to the top, right? With these 4-star generals, really like they could take our findings and operationalize action. So what I realized is that wasn't always the case, because I've sometimes worked as part of teams where we were like embedded with mostly like with the researchers, which, hey, by nature, I'm a research person. But what I realized is that it was harder to translate that into action and impact. Sometimes it almost felt like we were also part of like a marketing campaign, like, hey, we care about AI security, but there wasn't much impact into the operational side of things. So I would say, really where I could almost tell, like, if you tell me the red team, where does it live within the organization? And I think Raman Chaudhry says this in her, anytime she talks, that like where a red team lives within the org tells you a lot in terms of how effective they're going to be to exert change, because sometimes you need to deliver bad news, or sometimes you need to. So again, I think depending on where you live within the org, the effect of impact is really affected. Now, of course, another thing here is you need to be empowered to be able to do this type of analysis with minimal amount of constraints. And sometimes that makes people nervous. Of course, you need to have rules of engagement that are not going to just crazy things like, chloroform security guards or whatnot. But the more empowered a team is because you're not going to limit an actual adversary, right? So you need to really, to be a true red team, you need to be able to use the full set of tools and access that you would consider. So that's tricky. If you can manage that to get a true set of kind of be empowered to do that, that's when the magic starts. I'll give you a counterexample where that wasn't the case. We had I won't name the organization, but we had an organization that had kind of a face identification application. And I had an intern. I mean, granted, this intern was like from MIT, super smart. She was like amazing. But like I told her to kind of bang on the system for a little bit. These are not the actual results, but it's using the same code. But basically what we showed is that this is the training data, right? And then you could show that after a couple of iterations here, you could basically approximate that training data really closely. In fact, so this is the training data. This is the recovered, and this is the actual training data. And this is an intern that hasn't finished their undergrad, granted super smart, but we presented these findings, but it took me a lot more arguing for them to take this seriously and mitigate it than it would have, because we were part of some we were deep in some subdomain in the application space and not higher up in the org to be able to deliver some of that and hard cutting news. So the other thing I learned is I kind of was at one point concerned that we were becoming like the red tape, like, oh, if you're going to field something, got to go red team it with these people and check the box. It's been secured. And I was kind of depressed. I was like, oh my God, what have we become? Yet another just list of things that people have to do. So I really have fought hard to make it clear that this is more of like a training an organization from like a mindset to, think about security, its security posture, but never be satisfied that this has just been officially red team and we have the official seal of security. I would, I'm sure that those of you guys have been in a similar position. You have to fight that balance between, taking this seriously, but at the same time knowing that there's no guarantee. And it's an ongoing battle, at least in my part of the world. And just as an example, we had a system it was really cool. I mean, they were doing deploying on premises, these huge container ships of GPUs doing machine learning inference. And I was a little bit bummed because every time they would like deploy these things, they're like, well, has it been red team by my MITRE team? Okay, check. Okay, and it just became a check box. And that's when I kind of started fighting it, saying, listen, that's not the way we want to treat this. It's really kind of an ongoing thing. It's not like a discrete red team, check the box, but we should continuously think about doing this as a state of practice. The other thing is that early days, I showed those like, fancy kind of, I talked about how proud I was about the infrared adversarial pattern. And I think we tended to over-index on like fancy attacks, like things that are exotic and cool, just because we're researchers and we want to push the envelope. But what has become evident is you really need to consider kind of dumb attacks. And in fact, I like to quote Ram and Hiram, who talk about, a low skill doesn't necessarily mean low impact. And I really resonate with that. I think it's something that folks in the community have recognized for a second, is that we sometimes get a little carried away with some of these kind of exotic attacks, and you need to consider more holistically about what's possible. On the right-hand side, what you're seeing is just a really dumb attack against ID.me that just involved like a guy wearing a wig. It's like, this is not a thermal infrared side channel. It's just, these are the type of things that you also need to consider. The other thing that for me was kind of insightful was, I, like many of you guys, I go through my stack of, archive.org papers every week. And it's like, I'm reading what people are thinking or doing, but it was a bit humbling to realize it's much harder to actually take these papers and make them work in the real world. I think people just kind of think, oh, it's like you just download the code and you're good to go. That example that even the adversarial pattern that I talked about, I mentioned we needed to optimize that to work across different times a day. There's geometries, there's atmospherics and all that. If you're doing things like expectation over transformation for adversarial patch, are not part of that kind of academic work. So you need to realize that there is usually a significant delta between what's kind of in a published paper, and is this actually something that you can meaningfully pull off in the real world. At least I found that. So there's usually a significant kind of R&D cost to actually make it operational. The other kind of thing that I've learned is that there's this great publication that I always go back to from the folks at Google about the hidden technical debt in machine learning, that I always, if you haven't read it, I really recommend it. It's like fantastic thinking. And basically the gist of it is, we all tend to focus on a lot of these kind of emerging attack surface when it comes to kind of machine learning enabled systems. But let's not forget that they're actually a small part of many of these larger systems, right? Here you have this little machine learning code box in the middle, but you have all these other things, right? You have, configuration, feature extraction, analysis tools. And let's not forget about that when we're doing kind of security analysis and really thinking kind of more holistically, systems level. I think we need, to encourage the community to take that perspective. I'm a victim constantly myself of like going to the, cool niche new things, but I also need to like force myself to step back and look at that systems view. And that can help you also as an attacker, by the way. So like when you're thinking about from a red team perspective, we've found some crazy vulnerabilities when you don't just look at the machine learning part of it. I'll give you an example here. This was like this is a couple years old at this point, but we had a DJI drone that had basically it was doing dumb like feature tracking. Like this is like classic SLAM to do visual geometry. And that turned out to be a pretty big vulnerability that you can demonstrate kind of an attack. And what we did was we basically generated it kind of like an attractor that sucks up all those feature points that you're seeing over here. And then basically at that point, you don't have enough geometry to really basically reconstruct your scene. So at that point, it basically, we saw in the code that there's kind of like a panic fail-safe mode that it basically enters into. So it's really crazy that with like a, a $1 piece of paper, you could like land a little commercial drone with just that simple thing. So that was an interesting kind of demonstration that when you take that systems level view, you could discover some of these possibilities. So the other thing that I learned was this idea, we talk about black box and white box, but I was talking about there's like 51 shades of gray. There's all these different gray box is something that I think as a community, we need to start figuring out how to like capture more effectively, because there's just so many gradations. And I don't know if, I think, do we need to consider things like, there's on the inference or kind of on the training and inference side of things, there's, there's this idea from Google from the like, model cards. Is there an equivalent of that from an attack perspective that could help us add a little bit more clarity? I would love to be able to read a paper and right away look at the right-hand side, just like when you look at an architecture. I want to know your access model. What were you assuming? Because sometimes I'm deep in the paper, I'm like, this is way too much of an assumption. You're assuming you have like code access or your root already in the computer. At that point, it's like a little bit difficult for me to think about how that translates. So I learned to really think about that there's so many different variables in the gray box area. And we also had to build a lot of tools to move things from, black box to white box. So the degree to which that you're able to lighten that gray box extent helps you as an attacker, right? And there's all kinds of tooling that we had to build. Basically, tooling that allows you to understand even like what is the geometry that this model has been trained on, and what is the family model, like the model family. Even if I just know that it's based off of ResNet or it's based off of GPT-3, that gives me, so there's these basically levels of information that you can get. And the tooling that we had to develop was about being able to reveal that, set of attribution. And, I would say that, as a community, I think having discussions about those like gradations of gray box and what that means, I think it's something that it seems like an opportunity there for us. So here's an example of like a such tool that you're now able to basically take a API level access, and it pretty quickly converges. It basically does like a triplet loss. And basically it tells you, yeah, this model is based off of YOLO. This model is based off of, ResNet or whatnot. Pick your favorite set of models, and basically learns a distance function based off of just API access. And so I think these are sort of tools that I think teams are developing, and it will be interesting for different reasons. Even like IP protection reasons could be interesting. Okay, so these are probably, and I hope these are just things that, and I'm still learning, right? Basically every week I'm like, gosh, these are things that we should probably consider. But I thought since I'm here and, with kind of this fantastic community, I also wanted to just reflect a little bit about, we're in an incredible time. I mean, I was just talking with people before the conference started, like we have these really exciting companies that are popping up, doing really exciting work in ML security. We have some of the larger, tech firms that are also like putting out, really great tooling and services. So this is moving quickly, right? We're going from this is a hypothetical thing to we really need to address it, and here are commercial tools. So I feel like we're kind of at this inflection point where we now need to go from early days to now how do we work effectively to advance the tradecraft and as a community what is needed. And since I really appreciate the possibility of being here, I thought maybe I'd just offer up a couple things where maybe, together we could move forward and maybe what are the areas of opportunities for us to collaborate as a community to kind of advance things together. And I'd love to, hopefully, if there's time to just, get your guys' thoughts. What are things that we're missing? And then maybe walk away with areas where we can go back and collaborate. So the first one is, I think it's kind of a no-brainer. I've been working with people like Hiram and others on the team here. Like we need better ways of improving kind of AI security information sharing, right? So I think that's just kind of like, we need that. I think having mechanisms that are both kind of open and kind of public, but then maybe even kind of informal and like, hey, here's what we're seeing on our end are needed. I heard at some point there was something like the ML security saloon or something like that involved like an informal, people would host it across going to like from everything like Facebook and Microsoft. Maybe we need to revive some informal mechanism. Maybe CAMLIS is that. I mean, we just, we also probably need more open approaches. I don't want to be pushing, our little wares, but this is, we started, Hiram mentioned this, but there's one such approach is to take kind of like a MITRE attack type approach to kind of taking a taxonomy of all these different approaches and making it kind of a living, breathing database based on what we're seeing in the wild. So this is one such approach. I don't think it has to be the end all be all, but hopefully we need mechanisms that allow us to basically understand like a heat map of what's happening in the real world, so that then I could prioritize my red teaming and think about also how do you do things like mitigation. So that, I think that's one area, and I would encourage you guys, if you're interested in participating, reach out to us, help us shape it. If this is not the right approach, we could try, move and do something else. But I do think we need something to have better information sharing mechanisms. The other one is, you'll notice I did not show a single picture of a panda given thing. I feel I feel like we need to, as a community, like less turning pandas into givens, and really needs to start thinking a little bit more kind of broadly about the attack surface. In particular, some of the companies that I'm a huge fan of, there's some incredible stuff in the pipeline that is much more than just computer vision-y, like here's like hot dog, not hot dog. There's like really incredible stuff that is not AGI yet, but it's pretty strong ML, right? And it's doing consequential things. Well, you can hook it up to a credit card and it can go do things. So I think we're going to have to start thinking, we really need to get out of the habit of just staying fixated on these like niche things. I did a quick analysis, just downloaded all the papers, and it's like pretty crazy how many from ML security we're just way over indexed on like adversarial examples. So I'd say that like, let's have more and like work where we don't necessarily have to start with the panda given and go from there. So the last thing I wanted to just say, and I would love to open it up for your guys' comments or remarks. I don't know if you guys have read this book, Engineering a Safer World by Nancy Levinson. I was really inspired by it. And I think it really kind of gets at this idea that we can't procrastinate on some of this stuff, right? Some of these kind of engineering and science decisions that we're making right now, and some of these foundational models and architectures are really going to kind of embed potential vulnerabilities if we're not addressing them right now. We want to, you guys are all part of incredible teams. And I know that you're pioneering and moving forward the community to have this kind of culture of safety and security. So, how can we support each other in terms of, I know, sometimes we're challenged for organizations to resource that enough. How can we support each other to make sure that the organizations that we're part of are treating this seriously and resourcing it accordingly? With that, I want to just say I'm super grateful again to be part of this. I feel like it's that early days of us doing some cool things together. And hopefully some of these kind of errors and kind of little insights that I've made are of service and value. And with that, I'll just pause there and see if there's any questions for me. Thanks.